Okay, so let's look at these two problems. We'll start with the one on the left first. So this is a cantilever beam of length L with a load P at the end. I'm going to shortcut this a little bit and tell you, and I think you'll be able to see this. If I were to sum forces in the y direction, I would find that the reaction is up, which is positive shear, right? And it would be equal to P. I could also tell you that I could find the moment, and that moment would be in this direction and have a value of PL. What kind of bending moment is that? Positive or negative? Negative. So when I start my shear diagram, I'm going to start it with a value of P. Is it going to be positive or negative? Positive, because that's positive shear. And when I start my moment diagram, what am I going to start my bending moment diagram with? Negative PL. When I look out at this free end, with this applied force there, it's going to get a little tricky. So let's not talk about shear right now, but talk about moment. What's the moment at the free end? Zero. So I know when I draw my moment diagram, it's going to start at negative PL, and it better hit 0. So let's do the parts. So remember, the first one we like to look at is the change in shear is the area under the load curve. So what am I going to start my shear force with? Positive P. The change in shear from 0 to L is the area under the load curve. What's the area under the load curve? 0. So that means I should end with a value of P. I also know that the slope of my shear diagram is equal to the load. And what's the value of the load? 0. So I have a 0 slope, which is a horizontal line. So there's my shear diagram. So this beam has constant positive shear in it. You have a question? No? Let's do the moment diagram. It does. So we know our bending moment reaction is negative PL, so I'm going to start with negative PL. And we've talked that the free end, since it doesn't have an applied moment, has a moment of 0. My relationships tell me that the change in moment should be equal to the area under the shear diagram. What's the area under my shear diagram? It's a rectangle. The area is base times height. So the base is L, the height is P, so the area is PL. So if I start at negative PL and I add PL, what do I get? 0. Why is what negative? Because this moment is a negative bending moment. Not right-hand rule, bending moment. Right? Remember our sign convention? If you have a little chunk of beam, these moments are positive bending moments. So look at the left side and compare it here. It's not that, so it's got to be negative. Plus, how do you think that beam is going to deflect?
It's going to frowny face.
It's going to be half a frowny face. Yes, it is. So the final piece to this particular problem is the shape of the moment diagram. And the slope of the moment diagram is given by the shear. And what's the value of the shear anywhere? Constant, 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 equal to positive. So that means I have a positive slope. So everywhere on this curve, the slope is positive P. And there's my bending diagram. So you can see everywhere in this beam, the moment is negative. So that means every point on this surface, I have negative curvature. So where's the maximum moment in the beam? Fixed connection. What's its value? PL. What's the maximum shear in the beam? P. Where does it occur? Everywhere. Let's do another one. So what happens here? If I sum forces in the y direction, what's my reaction? Don't have one. If I sum moments here, I get a reaction that looks like this. Right?
Yeah.
What kind of bending moment is that?
Positive.
Positive. So I know I'm going to start with a shear of what here? 0. And I'm going to start with a moment of positive m naught. So let's see what we get. So I'm going to start with a shear of 0. It says the change in shear is the area in the load curve. What's the area in the load curve? 0. So that means I got no shear. The slope of the shear diagram is equal to the load. The load is 0, so I connect those dots with a straight line. So do I have any shear in this beam? Nope. Now I start my moment diagram. Do I know my moment at the left side? Sure. It's positive m naught. Oh, by the way, do I know my moment at the right side? Yeah. What is it? Positive m naught. So I know where I'm starting. I got to figure out what connects the two. Is that true? Well, the change in the moment is the area of the shear diagram. What's the area of the shear diagram? 0. So there is no change in moment. That's true. The slope of the moment diagram is equal to the shear. And what's the shear everywhere? 0. So that means I have a curve with 0 slope, which is a straight line. So where's the maximum moment, and what is it? It's m naught, and it's everywhere. Any questions about those two? We're going to do a few more. All right.